Hello everyone, in this video we're going to be doing more practice with scatterplots. I'm going to be showing you some more examples of data that could be linear or could not be linear. If it is linear, we're going to find the equation for it. And if you're given a table, we're going to find the equation for it. And we're going to be describing whether or not the correlation is strong, weak, positive, or negative. All right, let's get started. If you did the last lesson, and if this isn't your first time doing scatterplots, this should be super easy. If this is your first time doing scatterplots, just follow along. I'm going to be using Desmos.com as my graphing calculator. Okay, so now let's just start with this first question. If you were given a graph that looks like this, could you draw a line of best fit through that graph? If you draw a line of best fit that goes about halfway through the dots, like half of them are above the line, half of them are below the line, kind of like I just did right there. If you draw a line of best fit, are those dots pretty close to that line? I would say yeah, and this example, that looks like it's a pretty strong correlation. Okay, then if it is a strong correlation, if those dots do match the shape of a line, then we need to find the equation. We're going to do that by taking these dots, and we're going to be putting approximately where they are into Desmos. Okay, so I already have my table opened up, but if you didn't have a table on your calculator already, you would push the plus sign on Desmos and then do a table. It has x1s and y1s. The x1s are going to be whatever the x for a point is on the graph. So I have one point that's at -3 for x, and the y, if I just trace this, it looks like the y is going to be at about +3. So it's not perfect, but I would guess that it's +3 because this next one is a little bit higher. So I'm going to say that the next dot has a y of 4 and an x of -2.25. We'll continue. We have one that's a little bit less to the left, and it's at 10 high. So I'll say -2.1 with 10. We have this, and then the last one is at half of a space for x with, looks like we're counting by 5, so that's 32. 32 for y. Let's see what Desmos made for that graph. It looks like it's going very upwards. I don't think I can get the scale to be exactly like it is in on the picture here, but we have a graph of those dots. Then we're going to make a new equation, and that new equation is going to be y1. Then we're going to have to do the squiggly line, the tilde, to say is it going to be approximated. Y1 is approximately, we need m x1 plus b. And then Desmos just solved for the equation for us. It found m is equal to 9.00, so we'll just put 9, and b is equal to 28.15. If we zoom in on our graph here, we can see that, yeah, it's about 28, 29. That would be the right b. So for number one, we didn't say it, but yes, this is linear. Y is equal to 9x plus 28.15 is the best approximation. That is the line of best fit. But I'll say linear regression because we did use a calculator. We didn't just estimate with our own paper, pencil and paper. We used a calculator, so that's called linear regression. And the R value is 0.96. So this is a very strong correlation with those data points. Number 2 looks like it would be done very similarly. You just label the points in your table and then put them in the calculator. For number 3, we can see that these dots are all scattered everywhere, which means that there is no correlation. That is not linear, those points. This one is linear, and we could find the equation for it, but since it would be just like how we did for number 1, I won't do it. Just go ahead and do the equation for, okay, I'll do number 5 and then I'll do number 6. So let me just go ahead and clear out that table. Let me make a new table. This table is going to be 1 through 6 for x. Oh, we don't have a number 7. We only go up to 6. And then the y is 50, 45, 43, 34, 29. Oh, put the 29 in the wrong spot. With those data points, we are going to, well, the first thing you should do is you need to graph them. You need to graph that on your notebook paper. So these are your notes, and you're going to have to do something very similar on your actual practice. It looks like, well, our x's only need to go up to 7 because that's 1 past 6. And then our y's will need to go up to 50. So we need to go past 50. We'll go to 55. And then we'll see that would probably be 11 tick marks. Oh, maybe that's too many. I'll change that. Let's count by 5, 10. And now let's put our dots. 1 goes with 50. 2 with 45. 3 with 43. Cross-eyed, trying to look at this graph and make sure that I'm putting these things straight. It wants you to write the equation of the trend line. So let me just go ahead and make a fake trend line. It would be something like that. And then now let's see what Desmos says is the actual trend line. Notice that in this table, I have x2 and y2. Because that's x2 and y2, I need to change this equation so that it has y2 and x2 in it. Now it's going to make the right linear regression. It says our R value is negative 0.98, so that means that this is a strong linear correlation. Strong negative linear correlation, since R equals negative 0.98. I'll put 0.98, negative 0.98. And then the equation is y equals negative 4.91 plus our b, which is 55.2. And all I did is I just got those numbers from Desmos right there for m and b. It gave us the slope-intercept equation. I'll do one more. Oh, can I move my calculator? I can. Cool, I didn't know that. iPads can be weird sometimes. Okay, so we're going to need to change the data, and we will need to figure out how to make the scale. Okay, so since the gap between 87 and 92 is only 5 years, I don't really want to make my scale start with 0. Instead, what I'm going to do is I'm going to make my X scale count the years since 1987. That's what my x-axis is going to measure. My y-axis is going to be the total crimes in millions. And in fact, I should, okay. For my graph from the first example that I just did, it was just x and y. If you ever have data that's actually telling a story, or it goes with real world problems, you definitely need to title your x-axis and your y-axis. Okay, so the x-axis is the years since 1987. This first one, it's in 1987. So how many years is that? That's 0. And then I need to go 1, 2, 3, 4, 5. And then I'll put space for 6, but really we're only using 5. My y's need to go up to 15 million. And then I'll just split it into thirds, 10, 5. Then I'll change colors, and 1987 goes with 13.5. Okay, so here would be 12.5, because that's halfway between 10 and 15. So 13.5 is going to be, here's 13.25. So 13.5 is going to be a little bit higher than that. Next we have 1988, which is 1 year after 1987. So we have 0 and then 1. I'll just go ahead and label it so that way we don't forget. And that one is going with 13.9. So we'll just go slightly higher than the first dot. Then at year 2, 2 years after 1987, we have 14.3. So we'll go a little bit up. Then once again, a little higher. 14.9, so this is almost at 15. And then in the fifth year, we went down a bit to 14.4, which should be close to what we put for this second or third year. Maybe a little higher than what I just marked. So I would say that the trend line would be something like that. Let's see what the calculator says. So we're using 1 through 5, which means I can delete my data for space number 6. And then let me change these y's. Oh, I do need a 0. I'll just put 0 at the end. 0 with 13.5. The cool thing about using a calculator for our tables is that the calculator doesn't care if it's in order or not. Just as long as the ordered pairs are correct, it'll get the right numbers. So year 0 went with 13.5. Year 1 goes with 13.9. Year 2 is with 14.3. Year 3, 14.5. Okay, so if we zoom in on our graph, we can see that it looks better than our scatter plot, but if we do include the origin in our Desmos graph, then it looks a lot like our scatter plot. Okay, and let's look at our table. Our table is using x2s and y2s. That means that our equation needs to use y2 and x2, which it already is. So then the equation that's given to me right here, m is 0.22, b is 13.7. That is the correct equation. So let's say that this is a strong positive linear. Instead of using linear regression, I'm going to say that this graph is modeled by y equals the slope of 0.22 times x plus our y-intercept of 13.7. Strong positive linear correlation because our R value is 0.84, which is greater than 0.7, so it's strong. And the line of best fit was modeled by y equals 0.22x plus 13.7. The only other time you would have to do something like that would be like in number 6, but in these questions at the bottom, you do not. Okay, your assignment is going to be write the equation for number 2, do questions 4, 6, 10. Let's see how many questions that is. 1, 2, 3, 4, 5, 6. I don't think you need that last question. Today can be easy, but also if you didn't finish your Thanksgiving packet, work on your Thanksgiving packet. Do 10 questions, do 5 questions, get it turned in, fix your grade, be awesome at math. Good luck on your assignment.